Good morning. How's everybody doing this morning? It's a rainy, yucky day.
I'm tired.
Me too. It's the end of the week. Tomorrow is Friday, and then we have a weekend. So we've got 5. We got 3 more to come in. While we're waiting on the others to join us, does anybody have any questions that we want to go over before we get started? Anything that y'all are having trouble with, or? Let's see, I know. Let's see. Yes, it's April and Keely and Easton.
I had a quick question.
Sure.
Were we supposed to get all our homework that was assigned to us yesterday done today?
No. Like I said, you know, the homework that's assigned on Wednesdays and Thursdays isn't due till the next
I thought
Wednesday.
we were supposed to go over it and check it today, so I was kind of like, I didn't
No.
even...
No, because I know that's a lot to have gotten done.
Okay.
So no, we won't check it till next Wednesday. Well, I guess I'll just kind of watch for them to come on in. I'll go ahead and get ready and share my screen. Let's see. Go back to my Zoom. We're going to keep on talking about parallel lines today. Who knew there was so much to know about parallel lines? All right. Screen bigger so I can watch as they come in. Okay, so Easton says he's having trouble logging in. So let's give him a minute, ask him if he's trying the Wednesday or Thursday link. I bet he's, yeah, he joined the Wednesday class. There he is. All right, there's Easton. All righty, so we'll go ahead and get started with Section 3.5, so we've been talking about parallel lines, like I said, from the past several lessons. So I'm going to flip back for just a minute and we'll kind of So in the first section of this chapter, we just talked about, lines and angles. We talked about parallel and perpendicular. And then 3.2, we did proofs and perpendicular lines. So we were talking about, perpendicular lines intersect to form 90-degree angles. Let's see. 3.3, we started parallel lines and transversals, and we talked about how a transversal is going to be a line that intersects two parallel lines or intersects and it's not at a 90-degree angle. So as a transversal is going to be any kind of line intersecting a line that is not at a 90-degree angle. So that's going to be the biggest difference between a transversal and a perpendicular line. Is perpendicular lines intersect at a 90-degree angle and transversals intersect at other angles. Okay, so they're very similar in that they're intersecting other lines, but the main difference is the angle at which they intersect. And then the last thing we talked about was proving lines are parallel. Okay, so we went through that, and we had our converse theorems that we could use the angles to prove parallel lines instead of using parallel lines to prove angles. So now 3.5, using properties of parallel lines. We're just going to keep on going about our parallel lines. And so let's see, this is page 157. So it says using parallel lines in real life. When a team of rowers competes, each rower keeps his or her oars parallel to the adjacent rower's oars. If any two adjacent oars on the same side of the boat are parallel, does this imply that any two oars on that side are parallel? And so it says it kind of examines this question in example 1. And so it shows kind of the drawing of what would be like the boat, and then you can see what would be like the oars. And so it says proving two lines are parallel. Lines M, N, and K represent three oars above, represent three of the oars above. M is parallel to N, and N is parallel to K. So now you have to prove that M is parallel to K. So think about that. That's a lot like our transitive property, where we have two separate things being compared, but they each have one in common. So we're able to eliminate that one thing in common and compare the first and last things together. So it is given what I just said about the parallel lines, and we need to prove that M is parallel to K. So we can see that M is parallel to N. That's a given. And so when we look at where M intersects, we can see that that forms angle 1. And then we can see where N intersects, and that's angle 2. So we can use those corresponding angles and the corresponding angle postulate. So angle 1 is congruent to angle 2. And so that's the corresponding angles postulate. Then the next one is N is parallel to K. And again, that's in my given. So notice that the given, although usually we start out with the given as step 1 or as reason 1, you can also break the given apart. You don't have to put every single thing in the given in the first step. You can break it apart. So that's what they've done here, is they've taken M is parallel to N to be our first given, and then a couple of steps later, we're looking that N is parallel to K. So that's going to be statement 3. And so again, now with statement 3, they're saying now we have got that 2 corresponds with 3. Okay. So then once they've done that, we're seeing that we had our corresponding angles here, corresponding angles here. 2 was our common one. So then that means that now we can link 1 and 3. And step 5, that's through the transitive property. Okay. The transitive property allowed us to compare two things and then be able to compare the first and last. So now M is perpendicular to K using the corresponding angles converse. Okay, so let's look at that for just a minute. That was back in the last section, and that was corresponding angles converse was postulate 16, okay, and that was back on page 150. Again, we have so many postulates and theorems and things like that you know, even if you just jot them down on a sheet of paper and you've got one running list to be able to compare them to, that may be helpful as well. But they're just expecting you to recall these things. But that is coming from the corresponding angles converse. Okay, so now we've got some more theorems to add to our list and add to our blue folder. And so the first one is theorem 311. If two lines are parallel to the same line, then they are parallel to each other. So again, kind of like that transitive property, that if I show that these two are parallel to each other and these two are parallel to each other, then they're going to be parallel. Theorem 312, if in a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So remember, when we talk about perpendicular, if I've got one that's perpendicular here and it forms a 90-degree angle, and I've got another one that's perpendicular over here and it's forming a 90-degree angle, then I know that they're both going in the same direction, so they both have to be parallel to each other because they're both forming 90-degree angles when they're intersecting that other line. So remember, as long as the angles are the same, then we know the lines are parallel. Any questions about either of those theorems? Again, it's the kind of thing that if I'm explaining them and I'm not making sense and you're not getting it, don't hesitate to say, you're not making sense. It's okay. Sometimes I'm, you know, I know what I'm trying to tell you, but it might not come across. So be sure to let me know. All right, example 2, explaining why steps are parallel. In the diagram at the right, each step is parallel to the step immediately below it, and the bottom step is parallel to the floor. Explain why the top step is parallel to the floor. So it says you're given that K1 is parallel to K2 and K2 is parallel to K3. By transitivity of parallel lines, K1 is parallel to K3. Since K1 is parallel to K3 and K3 is parallel to K4, it follows that K1 is parallel to K4. So the top step of the top step is parallel to the floor. So again, using that transitive property, that if this one is parallel to this one and this one's parallel to this one, then this one's parallel to this one, so we can kind of jump up that way. Building a CD rack. So this is funny because you can tell how dated this book is. When's the last time any of you guys bought a CD? More than likely, you probably don't even have a CD collection. So yeah, this book is a little dated. But nevertheless, we will pretend like instead of downloading music, you're building a CD rack. Maybe we can just say a bookshelf. I don't know. It says you cut the sides, bottom, and top so that each corner is composed of two 45-degree angles. So what it's talking about is these two right here. So we've got the full 90-degree angle here, but each of these, to make this piece of to make the slant match this slant, they would each have to be 45 degrees. So if you're into woodworking and stuff like that, again, some of this will be kind of some real life stuff that you may encounter. Prove that the top and bottom front edges of the CD rack are parallel. So the given is that the measure of angle 1 is 45 degrees, measure of angle 2 is 45 degrees. We can see that the measure of angle 3 and 4 are going to be the same way. We're trying to prove that BA is parallel to CD. Okay, so we're trying to prove, based on those angles, that my top BA, my line across the top, is parallel to CD. Okay, all righty. So they've used a flow proof here, which is not my favorite, but we're going to go with it. So we have this part here, measure of angle ABC equals the measure of angle 1 plus measure of angle 2. And then they've broken it up, and here's my other part of the given. Okay, so each of these are givens. Okay, so they just broke the two givens apart. And then this one is going to flow down. So we're going to start with the first given, that the measure of angle 1, measure of angle 2, 45 degrees. So we go down and we see that the measure of ABC is 90 degrees, and that's through the substitution property. Then using the substitution property, we go down and see that ABC is a right angle, because we know that 90 degrees is a right angle, and that's our definition of a right angle. Okay? And then we have that BA is perpendicular to BC. Okay? And that's the definition of perpendicular lines, which is going to lead us down here. Let's go over to the other given. Again, BCD is 90-degree angles. BCD is a right angle. BC is perpendicular to CD. So basically on either side of this flow proof, they're giving the same information based on measure of angle 1 and 2, 3 and 4, and they're going through the same process, and then eventually we're going to meet down here that says BA is parallel to CD. Okay, and it says in a plane, two lines are perpendicular to the same line. I'm sorry, in a plane, two lines perpendicular to the same line are parallel. And that's what from theorem 311. Okay. Any questions about that? Again, I will not be testing you on flow proofs. The main thing is that we'll see them, we'll go through them. But anytime we've got our proof situations, we'll just be using the regular 2-column proof, and I will never just say, here's this, write a proof. So, alrighty, so the next page is dealing with constructions. We're not worrying about constructions right now, but it shows you that, again, if you wanted to copy an angle, you would just draw your original line and put a point on there. You use your, you can use your compass to open it up, put the point on the point that you're using, and make a swipe going one way. Then using that point where you made your swipe, you can put your point there and swipe to make the top. That will give you the angle that you're looking for. Again, same thing with parallel lines. You can use your compass to do that. I think now we are so, we've got so many graphics programs and so many things are computerized that realistically, if you're trying to do that, it can all be done on the computer, probably much easier. Okay, and so that is all for this section. Very, very short section. And so let's look at our guided practice. It says, name 2 ways from this lesson to prove that 2 lines are parallel. And so it tells us underneath it. That's funny, because it's kind of like, I wonder if they got confused with the student text and the teacher text, because it has the red answer in it like it does, or the pinkish answer in it like the student and like the teacher text. Okay, so if they are parallel to the same line, then they're parallel. And if they are perpendicular to the same line, so that's the 2 ways if you you can, from this lesson that we've talked about, to be able to prove 2 lines are parallel. All right, then for 2 and 3, it says state the theorem that you can use to prove that R is parallel to S. So in each of these, so number 2, we're trying to prove that R is parallel to S, okay? So if we look at this, and we have R is parallel to T, and T is parallel to S, which theorem over on page 157 is going to tell us that they are parallel?
Theorem 3.11.
Yep, 3.11. If 2 lines are parallel to the same line, then they are parallel to each other. And then for number 3, R is perpendicular to T and T is perpendicular to S. So we need to prove that R is parallel to S, and that will be theorem 3.12. In a plane, if two lines are perpendicular to the same line, then they are parallel to each other. Okay, so let's keep going. It says, determine which lines, if any, must be parallel and explain your reasoning. So let's take a look at these. I've got M1 and M2, and I have L1 and L2. So if we look at these, I could prove that M1 is parallel to M2 either by saying that we have that perpendicular line L1 or L2 is perpendicular. Okay, so I could use either L1 or L2 to prove that M1 and M2 are parallel, and vice versa. I could use M1 and M2 to prove that either L1 or L2 are parallel, because either one of those would be perpendicular. And then number 5, I've got the same, but notice that here I'm dealing with these angles here, okay? So when I look at these angles, notice the location of notice they didn't put the boxes in, but remember we talked about how if it's the same, if it's just a one swoop, that means that they're equal to each other. And what did we learn about alternate interior angles? Well, that's not alternate interior angles. I was thinking about the consecutive interior angles. What did we learn about consecutive interior angles? Remember, if we have consecutive interior angles, that means I can add them together and they equal 180. So if these two are the same measure and I can add them together to make 180, then I can divide 180 by 2 and see that these are 90-degree angles. So again, even though they didn't put the boxes there to tell us they were 90 degrees, you can still use the other, you can still use your other theorems and postulates that you know to be able to figure out that they are indeed 90-degree angles. And so again, if they're perpendicular, if it's a perpendicular line, then the lines are parallels. Number 6, draw any angle, angle A, then construct angle B congruent to A. Since we're not doing constructions, we'll jump over that. And then 7 says, given line L and point P, not on L, describe how to construct a line, so we won't worry about that either. So those are dealing with constructions. All right, so if we go through kind of this next section, state the postulate or theorem that allows you to conclude that J is parallel to K. So you're going to be looking back at postulates and theorems. The next one says showing lines are parallel. Explain how you would show that J is parallel to K. State any postulate or theorem that you would use. So same thing there. Number 14 says make a list of all the ways you know to prove that two lines are parallel. Let's look at that one for just a minute. Okay. Let's flip back. Let me see what page. How far back we need to flip. Okay, so if we flip back to page 143 for a minute, what we're going to do is we're going to kind of go through these and look on page 143. I've got the corresponding angles postulate, postulate 15. So that's the first one that we learned, that if they're corresponding angles, then the lines are parallel, or then the angles are congruent, which means it's parallel lines cut by the transversal. So that's going to be our first one, is corresponding angles postulate. Okay. Then underneath that, we have the alternate interior angles theorem, theorem 3-4. So alternate interior angles also tells us that they are proving parallel lines. Then we have our consecutive interior angles, alternate exterior angles, and perpendicular transversal. Okay, so each of those are going to give us, so corresponding angles, alternate interior angles, consecutive interior angles, and then the alternate exterior angles. Okay, and actually, so those were our first theorems, and then we had the converse theorems as well about using the angles to be able to prove. So those were the ones showing that lines prove angles, angles proving lines are over in 3-4 on page 150. Same things except for it's the converse. Okay, so each of those converse ones tells us that we can prove lines are parallel based on the angles. All right, so let's go ahead and take a look. Explain how you would show that K is parallel to J and number 16. Okay, so thinking about what you would need to, how you would need to use 55 degrees and 35 degrees. Think about what tells you that those would make whatever angle you would need to make, and then what let's see, parallel lines. And then the next section, naming parallel lines, determine which lines, if any, must be parallel. So we're going to go through those. Whoops. All right, so on this page, what we will do as far as assignments, I just wanted to kind of read through them real quick and make sure we were good with everything. So on page 160, 8, 10, 12. So numbers 8, 10, and 12 on 160. 161, we will do numbers 16 through 24 evens. So 16, 18, 20, 22, 24. Then over on page 162, actually won't do anything. We'll just go ahead and take a look. Let's look at the categorizing, starting with number 33. It says, tell whether the statement is sometimes, always, or never true. Let's look at number 33. Two lines that are parallel to the same line are parallel to each other. And we just talked about how that is always true. If two lines are parallel to each other, then they're going to be parallel to another line. 34, in a plane, two lines that are perpendicular to the same line are parallel to each other. Again, we talked about that as always. If they are both have the same perpendicular, then they're going to be parallel to each other. 35, two non-coplanar lines that are perpendicular to the same line are parallel to each other, and that's going to be never because they're non-coplanar. Remember, parallel lines have to be in the same plane. That is one of the rules of the definition of parallel lines. 36, through a point not on a line, you can construct a parallel line. And so that is going to be true because any line that I have, and if I have a point that is somewhere else, I can always construct a line that is going to be parallel to the line that I have. Okay. Alrighty, so we're going to go ahead and move on over to 3.6, parallel lines in the coordinate plane. Okay, so thinking about when we have lines on in a coordinate plane. So thinking about back from algebra when we talked about slope. Does anybody remember what we learned about the slope of parallel lines? Does anybody remember anything about the slope of parallel lines?
Rise over run.
Lesson.
Rise over run, that's right. So we're going to have, we're talking about, when we talk about rise, that's going to be our vertical change. So that means going either up or down. If it's a positive number, I go up. If it's negative, I go down. And then run means side to side. And so if it's positive, I go to the right. If it's negative, I go to the left. But if I have two parallel lines, what do I know about their slopes? That the two slopes have, I'm sorry?
They're equal.
They're equal. They're going to be the same. Remember that they have to be equidistant. They have to be the same distance all the way from the beginning to the end apart, so they never intersect. So I know that the slope of parallel lines is going to be the same. They're going to be equal to each other. Okay? So let's take a look at this, and it says goal 1, slope of parallel lines. In algebra, you learn that the slope of non-vertical line is the ratio, remember ratio is a fraction, of the vertical change, which we call the rise, to the horizontal change, which is the run. If the line passes through the points x1, y1, and x2, y2, then we can use our slope formula to be able to calculate the slope. So as long as I have two given points, I can name them x1, y1, and x2, y2, and I can use my slope formula to find the difference of my y values divided by the difference of my x values. Okay? So slope is usually represented by the variable m, so we usually say m equals whatever. And if you remember our slope-intercept equation, y equals mx plus b, where m is our slope and b tells us our y-intercept. And so now we're kind of making that connection back to algebra with some of this. Alrighty, so let's look at example 1. It says finding the slope of a train track. All right, and it says a cog railway goes up the side of Mount Washington, the tallest mountain in New England. At the steepest section, the train goes up about 4 feet. For each 10 feet, it goes forward. What is the slope of this section? So again, we can look at rise over run. So they said it goes up 4 feet. So we know that's going to be our rise. And then for every 10 feet that it is going forward. And so that's our run, meaning again, if it's going forward, it's going to be a positive number. So we've got 4 over 10, which we can go ahead and express. We could either do it as a fraction in lowest terms, which would end up being 2/5, or we can put it as a decimal 0.4. Again, since you can use, calculators or whatever, you can just express it as a decimal or again, as a reduced fraction. Okay, so example 2, finding the slope of a line. Find the slope of a line that passes through the points 0, 6, and 5, 2. So again, it does not matter which one you choose to be 0.1 or 0.2, okay? That was something I used to really get hung up on, is how do I know which one's 0.1 and 0.2? It doesn't matter. You're going to get the same slope whether you use 0, 6 as 0.1 or 0.2, and you're going to, or if you use 5, 2 as 0.1 or 0.2. It does not matter. The main thing that matters is that you have your x coordinates in the denominator and your y coordinates in the numerator. That's what matters. Okay, so if we let x1, y1 be the first point, 0, 6, x2, y2 will be 5, 2. And so we go ahead and plug in. So y2 is our red. So we have 2 minus 6, and then 5 minus 0. 2 minus 6 is 4. 5 minus 0 is 5. Okay, and also remember that when I have the slope being, they've got kind of the negative floating out front like this. If I was having to graph this, it doesn't matter. I could go ahead and graph it one way and have my negative with 4 and my positive with 5. So that would mean I would go down 4 and right 5. Or I could go ahead and have my negative with my 5, meaning I'm going up 4 and left 5. Okay, so because my negative sign can be with the 4 or the 5, it doesn't matter, because even when I swap them, that means I'm just going different directions graphing my line. So we can see here that based on that, now one of the things I also want to mention, just kind of a point of remembering, when I have a line that goes in this direction, when it goes from top to bottom and it's going from the left side to the right side, that indicates a negative slope. Okay, so you can see it is a negative slope because it has a negative sign. A positive slope starts low and goes high. Okay, so that's a positive slope where a negative slope is going to go down. Okay. Okay, so moving along, it says you can use the slopes of two lines to tell whether the lines are parallel. So again, we have postulate 17 that is dealing with the slopes. In a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. So that's another way I can prove. If I can prove that the slopes are the same, then I can prove that my lines are parallel. So example 3, deciding whether lines are parallel. Find the slope of each line. Is J1 parallel to J2? So if we look at J1 and J2, so not only remember, we can use our, we could look at those ordered pairs for each point, or I can always count my slopes. Okay, so remember, if I want to count my slope, rise over run, so you could look at this and they went 2 this way and then 4 that way, so that means my rise over run is 4 over 2. Okay, or I could go up this way, 1, 2, 3, 4, so I'm going up 4 and then right 2, same thing. Okay, here again, rise over run, they went left 1 and then up 2, or you could go up 2 and right 1. I'm sorry, I said left 1, right 1. So I could go up 2 and then right 1 there. So again, that's the same, 2 over 1. So in both of these situations, 4 divided by 2 is 2, 2 divided by 1 is 2. Okay, so I do find that my slopes are going to be the same. And I didn't even have to use my slope formula. Okay, I can if I need it, or you can just count it. But the main thing to remember is that when you write your slope, you have to do rise over run. So that's why I prefer to go up first and then to the right, because it helps me to remember to put my up number or my down number in my numerator. Okay, so you can count it. Just remember to put rise over run, which means the number expressing whether you went up or down is going to be in the numerator. Left or right is in the denominator. Example 4, identifying parallel lines. Find the slope of each line. Which lines are parallel? Okay, so here they did go ahead and use the slope formula for K1, K2. We can go ahead if we wanted to. We could count this one and see that we would go down 1, 2, 3, 4, 5. Okay, so I went down 5 and then 1, 2, right 2. So that means my slope of this one is going to be -5 over 2. Again, they have found the same thing right here by using my slope formula. I'm going to go ahead and count my red line. I see that I'm going to be going down 1, 2, 3, 4, 5. And then so I went down 5, so that's going to be a negative, and right 2. So again, that's -5 over 2. For a red line, I can come over here. Oh, I already did that negative. So the green line we said was -5/2. The red one was -5/2. But now I'm going to look at this next one. And I go down 1, 2, 3, 4, 5, 6. And then right 1, 2. So I went down 6. So that's a -6 over 2. and -6/2 will simplify to a -3. So we can see that that's the difference. That one is different. So we can see that the red line and green line are the same. So because K2 and K3 have the same slope, they are parallel lines. K1 has a different slope, so it is not parallel to either of them. So again, you can either use your formula or you can just count them. My thing is do what's easiest for you. If it's easier to count them, count them. Writing equations of parallel lines. So again, a minute ago I mentioned the slope-intercept form, the slope-intercept form of a line, which is y equals mx plus b. M represents the slope. B tells us the y-intercept. Now, one of the things to remember is that every time we graph a point, it's based on an ordered pair. So even though we say B tells us the y-intercept, remember that that means the x value is always 0. So when we look at an ordered pair for the actual y-intercept, it would be 0b. So that would be how we would graph that. So it says to write an equation of the line through point 23 that has a slope of 5. Now remember, if my y-intercept is 0b, the point they've given me is 2, 3. So I cannot just use that number 3 as that's the y value. That is not the y-intercept, okay? That is an ordered pair that is on that line, okay? But the way that I can use that 3 is in the formula y equals mx plus b. So here, we have substituted the number 3 for y. We have used that here. That is substituted for the y. We know that the slope is 5, so I've put that in for my m value. Okay, now I've substituted the x value, which is 2, right there for mx. So I know the value of y, I know the value of m, and I know the value of x, so now I can solve for b. So again, I would just go ahead and multiply. 5 times 2 is 10, so 3 equals 10 plus b. I would subtract 10 from each side, and I get that -7 equals b. So I can find that my y-intercept, now if it asked me to graph it, then I would graph it, but it doesn't. So all we have to do is find what the y-intercept would be. So then I could write it in my equation where y equals 5x minus 7. Any questions about that? So when I'm given an ordered pair, I substitute my x value in my equation for x, my y value that they've given me for y. They've given me my slope, and I'm solving for my y-intercept. Okay, so remember we talked about that parallel lines have the same slope. So in example 6, it says we are going to work on writing an equation of a parallel line. So what they're doing is they give us one line, and it says line N has the equation y equals -1/3 x minus 1. So we can see that our slope is -1/3. Line N2 is parallel to N1 and passes through the point 3, 2. Write an equation of N2. Okay, so they've told us that 3, 2 is going to be the ordered pair we're using for x and y. We know that the slope is -1/3 for the first line, so we know it's also going to be -1/3 for the second line. I'm going to plug in my values. So I plug in 2 for y. I've got my slope of -1/3. I've got 3 for x. So when I multiply -1/3 times 3, remember numerator by numerator, denominator by denominator, so -1/3 times 3 is going to be -1. So I'm going to add 1 to each side and find that b is equal to 3. So then I have to write the equation. So since I know that -1/3 is m and b is 3, my equation for my parallel line is y equals -1/3 x plus 3. Any questions about that? Okay, so again, we are on to guided practice. So let's go ahead and take a look at this. It says, what does intercept mean in the expression slope-intercept form? So when we're talking about the intercept, what are we talking about here? What does the y-intercept do? Where is it graphed? Does anybody remember? What does it tell us about the line? Alec unmuted. Do you have a guess, Alec?
I did, but not anymore because I know it's wrong.
It's going to tell me where my line crosses the y-axis. Okay, so remember my y-axis is my vertical axis. So the y-intercept tells me where the point is where that line crosses over that axis. Okay, that's all it is. Tells me where. So if we look, just look at number 7 real quick. So you can see that point A right there, that would be the y-intercept because that's where it crosses over the y-axis. Now notice it crosses perfectly at that point. This one right here, not so much. That one would be a fractional number, it would be a decimal, it would be hard to calculate that one. So anyway, or not hard, but anyway, so just, you know, we're looking at the y-intercept tells where it crosses over the y-axis, okay? And it doesn't always cross over at a perfect location. All right, look at number 2. It says the slope of line J is 2 and J is perpendicular and is parallel to K. So what do we know the slope of K would be? It would also be 2. All right, so it says, what is the slope of a horizontal line? See if y'all remember this. So a horizontal line running like this. What's the slope of a horizontal line?
0.
0, good. So horizontal line will be 0. What about a vertical line? Does anybody remember about a vertical line?
Undefined.
Undefined, good. Okay, so I can't remember, I don't think I've told this class this. I think it was my ACT prep class. I cannot remember where I heard this from, but I heard it recently and I thought that it was kind of funny, and it's just something that stuck in my head that it helped me to remember, okay? It's one of those stupid things, but it is what it is. So think about a baby can crawl across the floor. So it can crawl across the floor if it's a horizontal line, it goes straight, so that's the slope of 0. So a baby can crawl across the floor when it's horizontal, but a baby can't crawl up a wall. That's impossible. Okay, so when I think impossible, I think it cannot be done. So I cannot have a slope of a vertical line because a baby can't crawl up a wall. Isn't that stupid? I don't know why, but it stuck with me to help me remember. This one, slope is undefined because it's impossible, can't happen. This one, slope is 0. And it all has to do with, remember that division by 0. So if I had x divided by 0, I can't divide by 0. But I can divide into 0. So what that means is a horizontal line is going to have a numerator of 0. A vertical line will have a denominator of 0 because you cannot divide by 0. So that's where it comes from. All right. Number 4 says find the slope of the line that passes through the labeled points. So again,
Hey, ma'am, real quick, is April in the waiting room? Because she told me she.
Thank you, thank you, thank you. She's going. Sorry, April.
No, it's fine.
Okay, so what we'll do is I'll catch up in just a minute, okay? We're on page 168 going through some guided practice. So find the slope of the line that passes through the points. Again, you can use your slope formula, but I'm just gonna count it. and I'm gonna start at my top point and go down 1, 2, 3, 4. So I know that that's -4. And then I'm going left, 1, 2, 3. So I know that's gonna be -3. So I have -4 over -3. And remember, if I have two negatives, it's gonna become a positive. So I have 4/3. You can either use your formula if you want to plug in the numbers and do the math, or just count it. Let's look at number 5. Same thing here. I'm going to go down 1, 2, 3, 4. So since I've gone down 4, that will be -4, and right 2. 1, 2. So that'll be a +2. So -4 over 2 equals -2. Number 6. I'm going to start at my top number and go down 1, 2, 3, 4, 5. So I went down 5 and to the left 1, 2, 3, 4. Since I went left 4, I've got -5 over -4, which is going to be +5 over 4. I know that we're going, actually, we're not quite to break time. We're almost there. But what I was going to say is we've already covered 2 sections. I don't like to cover more than 2 in a day, because I know we covered 2 yesterday and 2 today. So that's 4 sections for the week. I don't want to pile too much on you. So actually, we're just going to finish up this guided practice and get our assignments, and we're going to be done with the instruction part of class today. So it's going to be the kind of thing where you can stay and work, and I'll stay logged in and you can work, or you can log out and do your work on your own, whatever. So it's up to you. But we'll go ahead and finish this up, and we'll just be done a little early today. Determine whether the 2 lines shown in the graph are parallel. If they are parallel, explain how you know. All right, so again, we could use the slope formula, or we can just count them and say A to C is going to be 1, 2. Oh, I've got my eraser on, not my pen. 1, 2. So I went down 2 and right 1. So that means it's -2 over 1. So that's -2. And then for B, I'm going 1, 2. So down 2, right 1. So again, that's -2. So my slopes are the same, so they're parallel. Number 8. To get from E to G, I'm going 1, 2, down 2, -2, left 1, -1. So -2 over -1 is a +2. And for for F to H, I'm going down 2. So I go down 2, and I do not go left or right. So I was trying to see, well, and I guess that would be -2 over 0, but that doesn't, and I guess it's because I made a vertical line going that way. So, but we can see that because I only went down 2 and I did not go to the left 1, then we can see that these are not parallel lines. Number 9, we're going to go from J to L. 1, 2, 3. So I went down 3, left 1. So -3 over -1 is +3. And then K to M, 1, 2, I went down 2 and right 1. So that's going to be -2 over 1, which is -2. 3 is not equal to -2, so they are not parallel. Okay? All righty. So number 10, write an equation of the line that passes through the point 2, -3 and has a slope of -1. So we've got y equals mx plus b. We're going to plug in -3 for y. M is -1, so, and then x is going to be 2 plus b. So I have -3 equals -1 times 2 is going to be -2 plus b. add 2 to each side. So -1 equals b. So now I've got the slope, so I would use y equals -x minus 1. So y equals mx plus b. I know that m is -1, so that makes my x value negative. And since it's a -1 is my value of b, it would be -1 in my equation. Any questions about that? Okay, so what we're going to look at is our homework for this section. So let's see, we'll do numbers 12, 14, and 16. 12, 14, 16 in the top. And then in the bottom. Let's just do 18 through 32 evens on this page. 18 through 32 evens. Page 170. We will do (34 through 44 evens. Now, what I want to mention about 42 and 44 specifically, it says write an equation of the line that passes through point P and is parallel to the line with the given equation. Okay, so notice that here they have given us a point. So the first thing we've got to do is write an equation for that point. We can look here and see that we're going to be using the same slope. Okay, and that tells us that it will be parallel to this line. Okay, so we're just going to be, that's why they've given you the two different equations. So once you write that equation using point P, you're going to use your slope from the parallel line that's been given. So that's how you know what the slope is. Same thing with 44. So now take a look at 44. It says y equals 3. Okay, so think about y equals mx plus b. Okay, if it's telling me that y equals 3, remember that's my b, why did the mx part go away? What would make that go away? What would it have to equal to go away? Zero, right? So if I have y equals 3, what kind of line do I have?
Horizontal.
It's going to be horizontal, okay? So if this is a horizontal line, then what do I know that the slope is going to be for this one? If a horizontal line, the slope is 0, then I know that the slope for this one will always also be 0. So I guess I'll just go ahead and tell you. So this one would be y equals 7. Okay. All righty. So like I said, we have covered 2 sections already. I don't want to just keep blowing through them because I want y'all to have time to process them, work through the work, and all that good stuff. So we'll go ahead and review homework real quick to make sure everybody has their assignments written down. You can stay logged in and work on homework, or you can log out. It's up to you. April, you stay logged in, and I'm going to review everything with you, and we'll get you caught up, and we'll be good to go. So let me go back to this one. This was page 168, numbers 12, 14, 16. Then we have page 169, 18 through 32 evens. And then we have page 170, 34 through 44 evens. Okay, so all in all, our homework is, I'll go ahead and just get a little page and write it down real quick so y'all can see it. Okay, so this is 924. We have page 153, 10 through 18 evens. Page 154, 20 through 20, 20 through 28 evens. Then we have page 168, 12, 14, 16. Page 169, 18 through 32 evens. And then page 170, 34 through 44 evens. Did I get that right? Let me look back at 153 and 154, make sure I got all that.
We have a 160 and 161 too.
Which one?
Page 160, 8 through 12, and then evens, and then page 161, 16 through 24 evens.
Did I not write everything down on my sheet? Hang on, let me go back. I thought I wrote it down before I moved on, but I guess I didn't. And go all the way back to the beginning. Make sure. Okay, so we started at 3-5 today. So that was our page. And where did I write that down? Hold on a minute. So 160, 8, 10, and 12. Page 161, 16 through 24 evens. Then 168. I don't know why. I guess 153 was last week's homework. That's why I didn't draw a line between the two. My bad. That was or not last week's. That was yesterday's. So let's go back to that. Let me fix that. So this was yesterday's homework. Okay. So page 160, numbers 8, 10, and 12. Page 161, 16 through 24 evens. All right, and that was from 3-5, and this is from 3-6. Now maybe I've got my head on straight. Okay, so like I said, you're welcome to stay logged in and work. I mean, you can take a break, obviously, and then come back and work and have me to ask questions, or if you want to go, you're welcome to go. If you go, then I will see you guys next Wednesday back in class. And I hope y'all have a great week, but let me know if y'all need help.
Bye, Miss Jennifer.
Bye, guys.
Also, just letting you know, you're like the best teacher ever.
Well, thank you.
Thank you.
There's no reason for me to keep you logged in if we're done and if you feel like you know what you're doing. So, all right.
Bye.
Y'all have a good week, but if you need help, hang on. All righty, April. We'll go ahead and get you caught up real quick. If you missed part of a day, today was a good day to miss because we didn't have much. They were very short sections. So let's go back, and what we're going to do is we are going to start on page 157. Get back. So on page 157, section 3.5, it was using properties of parallel lines. And basically what we looked at was it showed us the example of the rowing boat and the oars, and saying that the oars are staying perpendicular to each other. And so what we found was that like the oars in the boat, in example 1, it says that if my angles are going to be, you can see I've got angle 1, angle 2, and angle 3. And so we can see that if angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3, then angle 1 is congruent to 3. So we can see that they're all congruent. And so that was the proof that they gave us, was we had the given that M was perpendicular to N, and N is perpendicular to K. And so angle 1 is congruent to angle 2. And then N is perpendicular to K was our other given. So that means angle 2 is congruent to angle 3. So remember when we've said that two things are congruent to each other, and then we've said these other two things are congruent to each other, but they have a common thing. And in this one, it was that angle 2 was the common angle that they were both congruent to. So that's our transitive property of congruence. So we were able to see that 1 was congruent to 3, since they're both congruent to 2. So we were able to show that angle 1 was congruent to angle 3. Therefore, M was parallel to K. So that's what theorem 3.11 told us. If two lines are parallel to the same line, then they are parallel to each other. So in this example, if P is parallel to Q and Q is parallel to R, then we know P is parallel to R. And that's that transitive property, but that allows us to know that. Theorem 3.12 says in a plane, if two lines are perpendicular to the same line, then they're parallel to each other. So we can see that M is perpendicular to P and N is perpendicular to P. So that means that they are parallel to each other. Since these degrees right here, they're both at 90-degree angles. So as long as the angle measurements are the same, then we know that they are parallel to each other. Okay. Then we came over here and we looked at the example with the steps on page 157, I think. Is that right? I can't see my page.
158.
158. Okay, so explaining my steps are parallel. So basically it's saying we know that when we have steps, that if this one is parallel to this one, and 3 is parallel to 2, 2 is parallel to 1, so then I know that step 1 is parallel to step 4. They're all parallel to each other, because we just learned that if one is parallel to another and it's parallel to they're each parallel to each other, then I know that they're all parallel to each other. So it says you're given that K1 is parallel to K2, K2 is parallel to K3. By the transitivity property or parallel lines, K1 is parallel to K3. Since K1 is parallel to 3 and K3 is parallel to 4, then we know that 1 is parallel to 4. Okay. Then we talked about building a CD rack, and I said that, you know, probably nobody has CDs really anymore since we download music, but we can just say it's like building a bookshelf. So basically it's saying you're building the CD rack, you cut the sides, bottom, and top so that each corner is composed of two 45-degree angles. So that's up here. We can see where if we have this corner up here, and we need this piece cut at a 45-degree angle and this one cut at a 45-degree angle, we know that 45 plus 45 equals 90, okay? So we've got these two angles that equal 90 degrees. And then likewise down here, we would cut two angles that also equal 90 degrees. So what we are given is that the measure of angle 1 is 45 degrees, the measure of angle 2 is 45 degrees. And so that's where they started this flow proof over here. They took this given and started it over here, and then they said the measure of angle 3 is 45, measure of angle 4 is 45, and they started this one over here. Okay, so they just broke apart the two givens And then now it's going to flow down, and they're going to have the same reasons. You can see that 1 plus 2 is 90 degrees. 3 plus 4 is 90 degrees. And we know that 90 degrees is a right angle. So that's what they've given for both of these. And so since they're right angles intersecting, we've got the definition of perpendicular lines, which tells us that in a plane, two lines that are perpendicular to the same line are also going to be parallel. Okay, but again, I said we will not be doing flow proofs as far as like doing assignments or doing homework or doing tests. We will always use the 2 column proofs because to me the flow proof is a little confusing. Goal 2 was constructing parallel lines. We're not dealing with doing construction, so we're skipping over that. And that led us to our practice. Okay, so that was all we really had for this section, was knowing that 2 lines that are parallel to each other are also going to be parallel to a third line, and that 2 lines that are perpendicular to the same line are going to be parallel to each other. So that's what it's telling us through this. Okay. So basically a lot of these, it'll say like state the postulate or theorem. So that's when you're going back to, what was it, page 156? You're looking at theorem 311 and 312 to answer a lot of these. Okay. Now looking at the showing lines are parallel, it says we're looking at the angle measurements here. So the main thing is if my angle measurements are going to be the same, then I know that they're going to be parallel. We skipped number 14. We just talked through that. And then on this page, we've got 16 through 24 evens. And again, we're using those postulates. And then for number 16, we talked about how if I add 55 and 35, what does that equal?
55, 35. It's 7. Wait, no. I can't do mental math anymore.
It's okay. What's 5 plus 5?
10.
10. So I put down my 0, carry my 1. So now I have 1 plus 3.
4.
And 4 plus 5.
90.
90. Okay, so we see that those two add together to make 90. What do we know the measure of that one is? If it has the box.
If it has the box, and it's 90.
It's 90. So we know that if these two angles equal the same thing, then these lines are parallel. Okay, because they intersect a perpendicular line, and we know that when they intersect a perpendicular line, it's 90-degree angles. Okay, so that's 16. For 18 and 20, again, it's going to be the kind of thing where you're having to look at the angles. You're having to look to see, are the angle measurements the same? Are they corresponding? All that good stuff. Because remember, the angles would have to be the same to tell that they are parallel. 22 and 24, determine which lines, if any, must be parallel and explain your reasoning. So again, you're telling why they would be parallel based on the angle measurements. Okay, and that's all based on theorems 311 and 312. Now moving on to the next section. Parallel lines in a coordinate plane. This is referring us back to algebra. Remember in algebra, we talked about the slope of a line. And we talked about the slope of a line compares the rise over run. And that's talking about its vertical change. Is it going up or down over the horizontal change, meaning side to side? And so when we got the slope of parallel lines, we know that the slopes of parallel lines are equal to each other. Because remember, they have to be the same distance apart to keep from crossing over or from intersecting at any point. So we have the slope formula that we can use if we're given 2 points. We can plug in our points and calculate. So that's what we're doing. And example 1, it just said in the problem, it said at the steepest section, the train goes up 4 feet and then it goes 10 feet forward. So the rise over run is 4/10, which is 0.4. Example 2 talked about finding the slope of a line. So again, we can use this slope formula here, the y2 minus y1 over x2 minus x1, or we can always just count it, okay? So when I count my slope, one of the things the book does side and then down. I prefer to go up, down, and then to the side since my slope is rise over run. I would rather do my first thing that goes in the numerator first. So if I'm going from this point 0.06 to this point 0.52, I'm going to start at my 0.6 and go down 1, 2, 3, 4 places. So I went down 4, and then I'm going to the right 1, 2, 3, 4, 5 places. So I'm going down 4 and to the right 5. So I have -4/5. So my slope is -4/5. See, even when they plugged it in and did the calculation, it's -4/5. So the slope will be the same whether you count it or whether you just plug it into the equation. So you can do it either way. Then postulate 17 tells us that if the slopes of 2 lines are the same, they are parallel. So that's all it says. If the slopes are the same, they're going to be parallel, and we can use that to prove that 2 lines are parallel. So example 3 was deciding whether lines are parallel. And so what we did here is, again, I just counted them. Instead of using that slope formula, we just said to get from, let me erase them so we can go through them. To get from this point to this point, I can go down 1, 2, 3, 4. So if I'm going down, that would be -4, and then left 1, 2. So that would be -2. So -4 over a -2 is a +2. Again, here, I can either go up and right or down and left. 1, 2 down. So that gives me a -2, and 1 to the left is -1. So -2 over -1 is a +2. So my slopes are the same, so I know they're parallel lines. We did the same thing in example 3, but we were comparing 3 parallel lines to determine which ones were parallel to one another. When we counted the green slope, we found that it was -5/2. The red slope was -5/2, but the blue one calculated to be -3. So we found that these 2 slopes were the same, so we knew that the red line and the green line were parallel to each other. Are you comfortable about counting from point to point to get the slopes? Are you good with that? Okay. I just don't want to rush too fast over something if you're not comfortable with it. The next one was writing equations of parallel lines. And remember that y = mx + b is our equation of a line that tells us the slope and the y-intercept. Slope is the m value, y-intercept is b. And so we can write an equation of a line if we are given a point. So like in this example, they gave us the point. They gave us 0.23, okay? That is not the y-intercept, because remember, a y-intercept has 0 as my x value. So if my x is not a 0, then I'm not dealing with my y-intercept, but I can still write an equation of the line and solve for b. My slope is 5 in this one. So I have my 0.23, my slope of 5. So what they did is they said, okay, this is my y value. So they plugged it in for y. My x value is 2, so they plugged it in for where my x is. My slope is 5, so they plugged it in right there. So then 5 times 2 is 10. And I've got 3 on the left side, so I take away 10 from each side, and we find that b is -7. Once I see that b is -7, I still need to put it into y = mx + b. So I'm going to have y = my slope is still 5, 5x - 7 is my equation of that line. Okay? Then we talked about how parallel lines have the same slope. So if I'm given the slope of one line, I can be given a point and write the equation of that line using the point and the same slope. And just like we did in example 5, I would do the same thing. I plug in 3, 2 for my X and Y values. So I'll erase this right here. It told me that my first line, my slope is negative 1/3. So I know that for my second line, it's also going to be negative 1/3. I'm using 0.32. So I plug 2 in for Y, 3 in for X, and then I use that same slope. Negative 1/3 times 3, remember that would be negative 1/3 times 3 over 1. So numerator by numerator, that's going to be negative 3 over 3 times 1 is 3, and negative 3 divided by 3 would be negative 1. So that's what they got right there. So 2 is equal to negative 1 plus B. So I can add 1 to each side, and B is equal to 3. So if I know that B is equal to 3, I can write it in the equation where Y equals negative 1/3 X plus 3. So the first section was just learning that parallel lines theorem and the perpendicular lines theorem. And then this section was about writing equations using slope-intercept form, knowing that parallel lines have the same slope. So in the guided practice on this one, we talked about how, number one, what does intercept mean in the expression slope-intercept form? We said that the intercept, the y-intercept, is where my line crosses the y-axis, okay? So like if we look at number 7 right here, I can see that my line crosses the y-axis right there at that point, okay? And so that's what my y-intercept is where it crosses the y-axis. Number 2 says the slope of line J is 2, and J is parallel to K. So the slope of line K is also going to be 2. Whoops. Okay, since they're parallel, they have the same slope. All right, we said horizontal line. Horizontal line goes side to side, and it has a slope of 0 because it's going to be consistent. It does not have any vertical change. Okay, and that's the same as when we calculate a slope and we end up with a 0 in the numerator. We know that's a horizontal line. And then a vertical line is the one that goes up and down, and we said that that slope is undefined because this is when I end up with a 0 in the denominator, and we can't divide by 0. And so that's why it's undefined. For 4, 5, and 6, we just counted the slopes up because it said find the slope that passes through the labeled points. So we calculated slope. 7, 8, and 9, we had to determine if our lines were parallel, and we did that by counting the slope. We went from point A to point C, found that this slope was -2. From B to D, it was also -2, so those are parallel. For number 8, when we counted the slope from E to G, I got 2, and from F to H, I had a -2, so those are not going to be parallel. Number 9, going from J to L, my slope was 3. And from K to M, my slope was -2. So they are not parallel because those slopes are not the same. Then I think this is where you came in, was on number 10. Write an equation of the line that passes through point 2, -3, and has a slope of -1. So again, we were plugging that into y equals mx plus b. Since our point is 2, -3, let me erase this and we'll go through it. Okay, our point that we're using is 2, -3, and actually what I'll do is, that's x, this is y. So when I do y equals mx plus b, what is y going to be?
-3.
-3 is equal to, they told me that my slope is -1, so I'm going to have -1 for m. What is x going to be?
2.
2 plus b. We're going to try to solve for b. So I'd multiply -1 times 2 is going to be -2. So I have -3 equals -2 plus b. So I'm going to add 2, and -3 plus 1 is a -1 equals b. So since -1 equals b, now I need to write the equation of the line. So I'm going to have y equals, instead of doing, remember my slope is -1, so I'd have -1x, and my b is -1, so I'd have minus b. So I could write that as y equals -x minus, oh, not b, duh. We calculated it to be -1. So y equals -x minus 1 would be the equation of that line. Okay. I know that's kind of a rush through. If you have to go back and look at the video in the slower version, or if you just need help, be sure to let me know. If you want to work on this right now, you can work on it while you've got me to help you, or you can work on it on your own. It's totally up to you.
Thank you.
You're welcome. Welcome, welcome. How you feeling?
Tired and busy.
Yeah.
But
You have a ball
work
game?
on Tuesdays. I mean, not really. I mean, it's not that long because Miss Gwen's daughter is getting married, so we don't have history
Well,
at
good.
12:40.
Okay.
But yeah.
Well, good. Y'all have a ball game this weekend?
Yes, we do.
Is it gonna be home or away?
It's away, and then like I perform halftime, and then right after halftime, I have to leave because I have a church retreat
Uh-huh.
like an hour away
Oh, wow.
at Winnetasca. So.
That'll be fun.
Mhm.
Well, good. Good, good. Well, all righty. Well, do you want to stay and work on this stuff, or do you want to work on it later?
I'll probably work on it later.
Okay. Well, that's fine. If you have any questions, just let me know, and I'll be happy to help you. Okay. Well, have a good week, and I'll see you next Wednesday.
Bye.
All right. Bye-bye.